how the assessment or the different rounds will progress, right? So we are all sitting here for Accenture's what role, guys? We are sitting for associate software engineer, right? We are all sitting for associate software engineer. This is the role that you're sitting for, and our package is 4.61, right? And how this progresses is initially you all had registered. Now, post your registration, you will get an assessment. That assessment will be a cognitive or a technical assessment. Initial assessment is cognitive or technical assessment. Now, what happens is in this cognitive or technical assessment, you've got 6 sections to go through, right? How many sections are there in cognitive and technical? We've got 6 sections, right? Now, each section, I'll just explain each section. I hope this is visible. Yeah. So your first section will be English ability, right? Your second section will be your critical thinking. I want you guys to note this down or take a quick screenshot because moving further, this information will be useful for you to place. Yeah. Next is your abstract reasoning, right? So third section is your abstract reasoning. Fourth section is your pseudocodes. Fifth section is your MS Office and computer applications. And final section is your networking and cloud security. You can call it security or you can cloud computing, right? So these different sections we have in order to these sections we need to clear in order to move to our next round. Now, once I'll just explain you how different questions. So, cognitive and technical round will have 90 questions overall, and all these 90 questions, you've got a timer of 90 minutes that kickstarts as soon as you press the start button for or the proceed test button in your exam portal. Now you've got 90 questions, 90 minutes. How does this 90 questions split up across different sections? So your first section is English ability, which will be of around 17 questions, right? Your critical thinking is of 18 questions. Yeah. Your abstract reasoning is of 15 questions, right? Your pseudocodes are 18 questions, right? How many till now? 17 plus 18 is how much? 35. 35 plus 15 is how much? 50. 50 plus 18 is 68, right? MS Office and computer applications are 12 questions basically. Cloud and networking, how much? 68 plus 12 is 80, right? So total 90. 90 minus 80 is how? 10 questions. So this is your split up basically. This is your split up. In your cognitive and technical round, we've got 90 questions, 90 minutes. 6 sections are there. Each section I've given here along with the number of questions. Now, the cognitive part basically comprises of your critical thinking, abstract reasoning, right? The technical part comprises of your pseudocodes, MS Office, and networking. English itself, stands alone. But in general, what happens is you need to cover basically all the bases in order to clear this particular assessment. Now, when I say what do I mean when I say this, what do I mean is, say for example, if there is a cutoff called X percentage, you need to score that X percentage in your English ability. You need to score that X percentage in your CTAR. CT is critical thinking, AR is abstract reasoning, and you need to also score your X percentage across these 3 sections. Now, this make sure that you are not just particularly good in one particular section so that you can pull off the overall cutoff, right? You need to be making we need to make sure that we are scoring that particular cutoff in every section that we are. These sessions that are going to happen from today, from now, maybe within 15 minutes, we'll start our first session on networking and cloud security. Every session is pretty important, guys. Every question that is discussed is important, as this will help you understand how different questions are being asked and how different questions will be asked, right? And how do you attempt, how do you approach each question? and what different concepts each of these questions are covering, right? Now, this cognitive and technical round, basically, after this, you shall be receiving, if you clear, obviously, which I hope you all do. Now, after you clear this particular round, are you are given a coding round. Okay, immediately. This is immediately as soon as you finish your cognitive, as soon as you finish your cognitive and technical assessment, you will be immediately pushed forward for a coding round if you clear that cutoff. There itself, you'll receive a congratulations message stating that congratulations, you've successfully completed cognitive and technical assessment and you've passed. Let us take you to the next round. The next round is a coding round wherein you will be having two coding questions, right? And we've got 45 minutes. We've got two coding questions and we've got 45 minutes to cover those two coding questions. Now, there is no language barrier here, right? Language barrier as in you can't, I don't mean Telugu, English, or Hindi. Language barrier as in there you can write the code in C language, Java, Python, C++, a language of your choice, or the language that you're trained in, either way, right? So cognitive and technical, post which you will have a coding round after coding round. If you pass that particular coding round, general trend I'll tell you, in my opinion, among those two coding questions, it is generally recommended to clear at least 1.5 to 2 coding questions, because a lot of people are writing this particular examination across India, right? And what makes us stand apart, right? We don't want to be among the crowd. If we are to stand apart, then we need to make sure that at least 1.5 to 2 coding questions we are clearing, so right, it helps us through the final selection process, right? Helps us or gives us additional marks throughout the final process, right? Now, one question that I have been asked is cognitive and technical assessments, 90 questions, 90 minutes, right? And there's no section, as in there's no section timer, no section timer. You can switch between sections and questions. Now, what this means is, say for example, you are perhaps in on your first question, then you can also immediately jump onto your 90th question also. So there's no particular order in which you are required to attempt this particular exam. You can start from your first question, directly move to the 90th question, come back to your second question, go to your 54th question, right? I hope you're understanding what I'm trying to say. There's no specific question after question like we've got in other examinations, right? So and also there's no section timer. Now that it is not that 17 questions, 17 minutes in for English ability. You can spend how much ever time in English, you can spend how much ever time in CT and so on, right? So these things comprise will be a part of assessment that you will be attempting on day one. I hope I'm clear. So this will be part of day one, cognitive assessment. Once you clear this, having a coding round. If you do not clear this, it will clearly state that sorry, you have not passed the test. So I think we are dropping you off the hiring process right now. So this will be some sort of message like this will only be given, which we do not want, right? We all want, what we are here for is for that congratulations message only, and also how to clear post that congratulation message for the coding round as well. Now I hope I'm clear with the day one process of hiring, which will start on 10th, 11th, 12th, whenever your exam is scheduled. Am I clear? If yes, then type a quick yes in the chat. Are you guys with me, guys? Did you understand? Yes, no, maybe. Yeah, clear? Yes, yes. Any questions? Any questions? One second. I did. Still going through the chat for any questions if I missed any. Sir, will the questions be of order? Can we use any programming language? Yes, you can use any of the available programming languages that they provide. Generally, they provide all the famous programming languages like your C, C++, Java, Python. They provide Go language also. So if you're interested in writing the code in Golang, then you can perhaps. Will the questions be of order? Oh, the Zoom is taking me. I just missed one question. Like English ability first, then followed by critical thinking. Yeah, provision of questions will be in order. Like the question paper has an order, as in first 17 questions are English only. Next 18 questions are CT only. Like for example, question number 1 to 17 is English. Question number 18 to do the maths, no? 35. Yes. 18 to 35 is CT. 36 to 50 is AR. So I hope you're getting me. No quantitative aptitude at all for Accenture, right? It is strictly only logical reasoning split across two sections, that is critical thinking, abstract reasoning. However, some mathematics is involved in critical thinking. I'm sorry, I'm not a CT expert, but we'll have Hemant sir, who is a CT expert and a legend himself, who will be taking your classes. So maybe you can ask mathematics related questions to him. But there is little mathematics. Do we have separate cutoff for individual sections? That's what I said, right? So generally what happens is you need to make sure that you're clearing pretty much that. For example, if the cutoff, I don't know what the cutoff is. If it is X percentage, you need to make sure that you are getting X percentage in your English ability. You're getting that X percentage in your CTAR. You're also getting that X percentage in combined of the technical. If we clear one section only, will we? No, that is not a scene. That is not the scene. You need, after you once you clear all the 90 questions, only then the timer will move and then take you to the coding round. Any negative marking? No negative marking. Let me just add that also. Decent enough question. So if you guys would like to take a screenshot of this, then please take a screenshot. As they said, there is an AI proctored. Yeah, it will be a proctored exam, guys. It is 100% a proctored exam. And there will also be face detection that will be involved capturing your face. Then throughout the exam, there will be a camera that will be proctoring you, right? Your own camera, basically. You will be proctoring. Any further questions? I don't want to waste further time on this. Is coding round and elimination round? Yes, it should be. It is. Consider it an elimination round while preparation. Yeah. Now once coding round is done, then you've got a communication round, which will be for 17 minutes. Now you will get a communication assessment link post you clear your coding round. Now this communication round will be for 17 minutes. And it will test you on basically your reading skills, your comprehension. That is, it is part of reading skills only, and it will take you through your soft skills. It will take you through your verbal ability. It will ask you to give a small jam session, not a jam session. It is a 40-second answer that you need to give, for which you will be trained again separately. That is not an issue, but I'm just giving you the process. So next round of hiring is a communication round, which will be for 17 minutes. After your communication round, we have your TR/HR interviews. So I hope I'm clear. I hope I'm clear, guys. I don't. If yes, then type a quick yes in this chat. Just a second. We've got a few questions. Where are the questions? Oh, the chat. Chat is here. As they said, there is an AI-powered assessment embedded to check any malpractice. In that case, can we use rough work, rough paper? Yeah, you can happily use a rough paper. That's okay. You will require to use a rough paper in terms of CTAR for drawing those circles. What do you call Venn diagrams? No. So for that you will be required. No, I am not the right person to provide you the cutoffs. Sorry. No information about cutoff of all sections. There will be a single cutoff only for all sections. It won't be an individual cutoff. Now, either way, let us prepare for clearing minimum of 80% of the examination, right? Let us prepare for clearing 80%. Let us imagine our cutoff for preparation is 80%. If less than 80% we are scoring, let us fail in our own minds. Then let us see if Accenture is passing us or not. No, while preparation, let us prepare that way. Yeah. Now, take a screenshot of this so that you understand. I hope you've taken a screenshot. Right. Now let us move to the meatier part of the discussion. That is your Accenture networking. So we are here to discuss further from now on for the next 2.5 hours. You and me shall be discussing Accenture networking and cloud security. I've got a lot of questions here with me. Let me examine one by one. Yeah, just a second. Hello. Yeah. Now, let us sit and start our networking and cloud computing. For these questions to be answered, I'm pretty sure if you're from a CSE background, you should have not just CSE, perhaps other backgrounds also. You must have your CN, right? Computer networks. You must have had your OS operating systems. Don't know how much you scored. Uh, but if you really liked computer networks as a subject like I did, and if you really like CO as a subject, computer organizations, then this will be a piece of cake. Some of you must also have cloud computing as a subject. Now this, even that should be a piece of cake. So this particular section, basically networking and cloud computing that we are going to discuss now, networking and cloud computing or your cloud security, this focuses more on your what do you call networking capabilities as in different protocols that you had in your CN. Now this, they won't be asking anything apart from the CN that you've learned in your BTech. Neither will they ask anything apart from the computer organizations that you had learned in your BTech. But what happens is generally they tend to go in deep, right? Like, so we need to make sure that whatever concepts that we are learning in depth. Uh, a high level understanding is good for answering quickly, but then if you want to score 100% out of, like, if you want to score 10 questions out of 10 questions, then an in-depth understanding is really required. And also what I feel is, since networking and cloud security is not a deductive section, right? Deductive section as in pseudocodes, right? For example, pseudocodes you need to solve. Yeah. You need to solve each code. Now, what happens is when you're trying to deduce a particular answer for a particular pseudocode, there is a chance of, you know, making a small mistake, maybe missing an iteration or adding an extra iteration, because of which the answer might go wrong. Sometimes the answers are also like options itself are like 14, 15, 16, 17, which is the right answer. So even if you miss one iteration, plus one, minus one, gone. That is why pseudocodes or deductive sections like your CTAR pseudocodes, what I generally feel is they tend to involve a lot of more human error than the remaining sections that we have, like English, MS Office, Comp Apps, and networking. So in order to push our score further, right, as I said, technical together, three sections, we need to cover a particular cutoff. In order to boost our score, and if you really feel that your memory is decent enough or your understanding of networking concepts is good, then networking really helps. Like really, really, really helps. What happens is, see, I'll be honest with you. Let's be very honest. Out of 10 questions, 4 questions so you'll answer straight off, right? Questions will be like what you're like. I'll just show you here. Out of the questions that we have right here, few questions you pretty much have learned bus topology, ring topology, and all, right? If not, we'll discuss. Few questions that I'll be discussing, they you will be answer like 4 questions, so you will be straight off be able to answer. I'm pretty sure about that. The remaining 3 questions will depend on how well you listen to the lectures that we're going to do. 7 questions are in your hands. The rest 3 questions depends on how good your understanding is again, right? Some solo research maybe, and further understanding of different cloud concepts, or maybe understanding different security concepts. If you're someone who is deep into cyber security, if you're someone who is deep into network security, then this particular section is a piece of cake. But in general, what I generally recommend all my students to have a target for is try to score somewhere above like 6 to 7 the minimum you need to score for networking. Hello? Yeah, 6 to 7 you need to score for networking. For that, we've got some material ready. Without any further ado, let's directly dive into this particular material. Now, networking, as I said, some basic concepts I want you guys to brush up. I will not directly dive into the questions altogether, right? Which we can, obviously, but let us spend at least 20 to 30 minutes understanding the basics of what different networking concepts we need to have, right? So that you can perhaps this basic concepts will give you the platform, the basement, in order to build further for your networking section at least. Now, first and foremost, everybody knows if you're from a CN background, different OSI model layers. How many of you know the OSI layers and these type of videos in the chat? I mean, at least you've heard. No? If you're from CSE, like I am, then 5 mark answer. Yes. I don't know how much you scored in out of 5, but yeah, 5 mark answer compulsory. Maybe a 2 mark answer. VSA thing, maybe. Yeah. So it is a compulsion. It is a compulsion for us to understand OSI layers if you are going through computer networks, right? If you're not understanding, 14 marks are there. 14 marks answer. I'm not sure. When I did my BTech, it was 5 mark answer. So yeah, so it is LA long answer question. Yeah. So also guys, a small update: if you guys are not joining with your roll number and name, then I might have to kick you out. Please don't allow me to kick you out. Word 423 20 and 3130423. Requesting you to please add your name here. We can rename yourself. I've given you the facility to rename yourself. Also, 1106. If you are someone who hasn't renamed your name to roll number hyphen name, quickly do it now. Yeah. We all want to be in this section. Nobody wants to be out. Yeah. So coming back to OSI layers. OSI layers is something that is pretty much common. Everybody has gone through. Also, can anyone tell me what apart from the OSI model, what different models work for? Tell me, I'll go through 2 models, right? Yeah. TCP/IP, right. So we've got generally 2 models, two big models that we basically go through. Right. TCP/IP. Right. Now, can anyone mean the full form of TCP/IP? No, pretty much that's something that you have established. This one is your IP model. Can you tell me the form of TCP/IP? Transmission control, transmission layer protocol. Right, right. Good, good, good. Now, without Googling, be honest to yourself. A lot of us have made a small mistake here. Can you give me the full form of OSI now? Let's be honest. We tend to forget. A lot of, I personally had forgotten last time when I was giving my examination. Give me the full form of OSI. Quick, quick, quick. Open system interconnection. Open systems interconnection. Ah, right. Did you Google it or Chat GPT? Or do you really remember? Huh? Yeah. No, Chat GPT. We Googled it. Yeah, see. Gotcha. 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 Now, yeah. So let us move further into different. See, what happens is for people who are not from computer science or a technical background, we've got friends and folks from different branches as well, right? So let us first what OSI model is, right? How do you understand an OSI model? It is basically a framework, right? OSI model can be, it is nothing but a framework or a model, just as the model says. Now it helps us to understand the how a network functions. I hope you know what a network is. A network is nothing but a collection of nodes. Say for example, I'll just break it down for everybody quickly without wasting any further time. Create something. So imagine this is your system. Yeah, this is your system 1. This is your system 2, right? Now this is your system 3, and this is your system 4. Now imagine there are 4 systems in your lab. Say which lab are we discussing here? Let us go for Java lab. Maybe everybody must have had Java lab. C lab, maybe C lab, everybody has had C lab, right? So imagine you are in your C language lab in your college, right? And there are 4 systems. Let us imagine 4 systems for now. Now these systems together, if you remember, are connected on the same network. When all these systems, this is each system, when every system is connected on the same particular network. Imagine if this is a network. If everyone is connected on the same network, then what happens is, imagine everyone on the same network. If each of them are connected to each one of them, then such a connection of different systems is called as a network. I repeat, imagine there are 4 systems and each system is connected to each other in whatsoever way possible. It can be using a connection protocol or a connectionless protocol. If you might connect it using a wire, you might connect it over internet, whatever it is. If each of the systems are connected to each other, I'm just breaking it down blatantly. Then in such a scenario, they are supposed to be a network. Now, I hope I've given you what in a particular network can be described as something called as a node, right? Each system is on a network can be called as a node. Also, a group of nodes in a particular network, right, or a group of nodes in a particular network is called as a domain also. Okay, we'll get to domains initially. Eventually, we'll get to what domains and all are. I'm just clearing out certain jargon for you so that while discussing different concepts, eventually you don't tend to confuse. Now you know what a node is. You know what a network is, and also now we know that a group of nodes together can also be called as a domain. Say for example, system 1, system 2 over a network together can be called as a domain, or system 1, system 2, system 3, system 4 together can also be called as a domain. Yeah. Now questions we've got? No. Now, now what happens is, in order to understand how this functions, basically how this particular network functions, how data is sent from system 1 to system 2. If data is sent from system 1 to system 2 over this particular network, then how does it start, how does it flow, how does it end up here, what are the different, in what method, or how does the data split up and go. Say for example, if you are to send a message from, in olden days, if you are to send a message from one kingdom to other kingdom, how someone used to send, they used to send a person, right? So how the person used to take the message from the king, write it down on a paper or a sheet, then or a scroll, basically, then take that scroll, get up on a horse, go to the other kingdom, get down from a horse, read out the information to the other king. So how this flow of information was before, and how the flow of information is there now, from system 1 to system 2, helps. This understanding is basically called, is basically a model in which we can do this is called as an OSI model. Another model in which you can do it is a TCP IP model. So what does OSI and TCP IP model helps us to do is, they help us to understand how a network functions. They helps us to understand, they are a framework in which they have some defined rules in which how we send a message from system 1 to system 2. Now, I hope I have made myself clear. Next, now there are multiple layers in which you can basically function. Right, the OS, as I said, it is a model, it is a function, right? So it is a model in which it functions. Basically, it helps us to understand how data flows from one system to other system, right? Now, there are multiple layers that it divides the nodes and the networks in. There are multiple layers in which it divides, right? So to the base level, we've got something called as a physical layer, right? To the base. So there are 7 layers in which OSI model has. So your base level is your physical layer, right? So your physical layer, basically, if you can read this, physical layer defines all the electrical and physical specifications for devices. This include layouts of pins, voltages, cable specifications, hubs, repeaters, network adapters are physical layer devices. Defines cabling and connections, transmit data over physical media. Now, how are you connecting on the first place? Are you connecting, okay, from a port? Like, if data is to flow from a port, how are you connecting? See, imagine if you want to send some images from your laptop to your mobile, we connect a cable, right? So that cable defines, is an example for a physical layer. So what different physical devices you're playing, the layout of the pins, type C port, for example. I'm just giving you a high overview example, but in general, there are different. We've got devices like hubs, repeaters, and all routers. Routers is not a physical layer device, but all these different what do you call physical devices, which helps us to understand how to transmit data over the physical media, right? Physical media as in from a wire, in a way, if I want to break it down, right? So this is defined in your physical layer. Your data link layer is nothing but it transmits. Next layer is layer 2. Layer 2 is data link layer. Now transmits frames of data from computer to computer on the same network segment, right? Ensures the reliability of the physical link established at layer 1, right? So whatever the physical link that we've established, we need to make sure that it is reliable, as in data is transferred in the right manner. Connection, just a wire is not enough. No, within the wire also data should pass in a correct manner, right? In segments, proper segments. So that reliability of data is maintained by data link. I hope you've understood. Physical layer is just connecting it from a wire. Imagine the same example that I gave you, from your laptop to your phone. the cable that you're connecting is the physical layer basically, but within that cable the data is transferred, right? From your, if I'm sending 5 files from laptop to your mobile phone, then each file one by one needs to transfer, right? And one by one transfer of files should also be in a correct manner. Imagine imagine you are sending 5 photos and one photo gets corrupted, then the reliability is lost, right? We want whatever data is there in your system to properly go to your mobile phone. Now in such a in order to do that, that reliability is taken care by your data link layer. Now how does it send data? How, in what format does it send data? It divides the data into frames. What is something called as frames? It divides the data into frames, and each frame will have its own headers. Each frame will have its data content. That data content can be an image, it can be any text file or something, but generally what happens is it transfers data in its own format called as frames. Now for, you can call it as a packaging also, right? So whatever data is there, it packages in forms, it converts it into form of frame. So Amazon, how does it, you select something in Amazon, Amazon packs it and sends, same concept here. It packs it and sends you, and it helps us to ensure the reliability of the physical. Standards define how data frames are recognized and provide the necessary flow control and error handling. Now there is also, we need to understand that how the flow, we it is extremely necessary how the flow is working, right? So there are certain standards that are already set on data link layer, which are not required right now, but eventually we'll get to know. But there are different standards that are set in order to understand how the flow should be. Different standards, each standard is a framework in itself, maybe, if you can call it as. What happens is it defines, okay, how do I break it down? You need not, one standard can say, same Amazon example, so for example, one standard might say that you need to pack it in a cardboard box, while another standard might say, no, no, you need to pack it in a paper or something, right? So there are different standards in which you can define how, and at the same time it defines the necessary flow control and error handling again at the frame set. So we, let us face it, we are in a practical world, so not every, a lot of different external factors also define the proper flow of data, right? So there is error handling always. So there will be, unless and until there is a transfer of data, there will always be some or the other errors. There can, it, that error can be bad quality, physical layer device. To that error can also be some improper dust in your pin. So, and also it can be an internal error again, as in the frames might not be packaged properly and sent. So it can be anything from that. So wherever there is an error, there has to be an error handling, and that is also being taken care of using those standards, right? Now link layer, data link layer is divided into two sub layers: MAC layer and logical link layer. Mac, I am pretty sure you must have heard of what Mac layers are, LLC layers are. Either way, you need not basically further repeat. It helps us to understand how Mac sublayer controls how a computer on a network gains access to the data and permission to transmit it. Coming back to our previous example of your laptop to your mobile phone, you can't just transfer anything that you want. Say for example, if you as a user do not have that access, then it will not give you permissions to send that transfer. While LLC is frame synchronization, flow control, error checking. So logical link control, basically it helps us in synchronizing frames, that is sending frames one after the other. Until one frame is sent, the next frame, there is a there are they are sent in intervals basically. So that synchronization, this error handling is something happens in one frame. If a frame basically tends to be errorful, then how are you maintaining the synchronization, how the flow is maintained, and all is taken care by the logical link control layer. Now that is it. We have understood what the physical layer is. We have understood what the data link layer is. Let us deep dive into network layer, one of the most important layers, I feel, in my opinion. Layer 3 establishes, maintains, terminates network connections, routes data packets across network segments. First, let us see here. First part, let us see, that is establishes, maintains, and terminates network connections. Now, the whole point is data is being transmitted from one device or a node to another device or a node, right? So in order to send that data, there has to be a network that is available, right? You can't simply send the data. No, Amazon can't just send you the package. There has to be a delivery person. There has to be a supply chain management system that is entirely put in place so that that data is sent properly from their warehouse to our house, right? That is why this particular maintenance of network connection, right, from one system to other system, first of all establishing that network connection, maintaining that network connection so that it is reliable throughout the process, is taken care by network layer. It routes data packets across network segments. Now, data packets again, right? Data is packaged in form of packets, and it is sent in across different network segments. Now, which data has to go to which system, which data has to go to which node, from where it has to go, from where it is coming, all that routing is controlled by your network layer. Translates logical addresses and names to physical addresses. This is not necessary as of now. We'll get back to it later. But next, transport layer provides transparent transfer of data between end systems or hosts and is responsible for end-to-end recovery and flow control. Coming back, let us reread again. This layer provides transparent transfer of data between end system or hosts and is responsible for the end-to-end error recovery and flow control. What does the name suggest? The name is transport. He is your delivery guy in plain and simple terms. Now it ensures complete data transfer. It makes sure that the data transfer is initiated and the data transfer is completed. So end-to-end data transfer like process is taken care by a transport layer. It is generally called as the most important layer in the OSI model. Now then sequences data packets, as in which data packet is of higher priority, it sends them first. Which data packet is of lower priority, it sends them later. Then requests retransmission of missing packets. What happens is sometimes during the transmission. Transmission means what? Transmission means the sending of data. Transmission, you're transmitting, you're sending data, right? You're transmitting data means you're sending data. So request retransmission means resending of missing packets. What happens is it sequences packets as 1 2 3 4 5 from system number 1. By the time it reaches system number 2, we only get 1 2 3 5. 4 is missing. Now, what will it do? Then transport layer should only again request for a retransmission of packet number 4. Now, why it happened? It might be because of any of the errors that are happening on layer 1, layer 2, or layer 3. It can be because of any errors across there. Now, it packages the messages more efficiently, more packet messages for more efficient transmission over the network. Now, since transport layer has access to every information that is out there, like what standard end system 1 is following, what standard end system 2 is following, it has information of those, so it decides and packages in the most efficient manner over the network. Next we've got session layer. Opens, manages and closes conversations between two computers. It performs name recognition and functions such as security needed to allow two applications to communicate over the network. Also provide error handling. Now what happens is, if a communication is to start, right? That is, if transport has to happen or data has to be transferred, first of all, same, coming back to the Amazon example, you need to first of all book that particular device, right? You need to or book that particular order, right? At least open up the app at least. So what happens is session layer, it basically starts the conversations basically saying that, hi, hello, this is system 1. Hi, hello, this is system 2. I want to send data from system from my system, that is system 1, to your system, that is system 2. So how do we go about? This is the conversation that is starting. Then system 2 will tell, okay, I've got these different protocols open, these ports are open. System 1 be like, okay, this port, it is open on my side also, so I'm send data from this port. Let us send data over this particular protocol, and data will go from my system to your system in this way. So all this conversation that is happening is responsible by session layer. Within session layer, it performs name recognitions functions such as security. Any security that is happening, it is taken care here. Yeah, needed to allow two applications to communicate over network. It also provides error handling. Obviously, it provides error handling. So whatever security you want to decide, then that discussion also happens between system 1 and system 2, happens over the session layer. Session layer is usually part of the OS, right? Converts incoming and outgoing data from one presentation format to another presentation format. Data encryption, text compression. Say for example, you might have heard, if you are a web developer, you might have if you've built any APIs, you must have heard of Xcoding format or your ASCII format. What character encoding? See, presentation layer, as in whatever data you are sending, what format is it in? Right? Is it in an ASCII format, or is it in an ANSI format? There are different formats in which data exists literally. We have something called as, you must have heard of ASCII, no? Each There are multiple, there are naming and numbering of each character that is there. So what happens is, ASCII data, while sending the data, which format the data is in? It can be A B C D E, but does it really mean A B C D, or does it mean maybe encrypted? Now A using a Caesar cipher can be a C maybe. So what cipher, or what any data encryption you are using, what data encryption you are using, uh, or what character format, character encoding this is, everything is taken care in which layer? This is taken care in presentation layer. Application layer is layer 7, gives user applications access to network. This layer represents the services that directly support the user applications, such as software for file transfer, database, email. Do I have to explain this? Even if not, I will explain. Gives user access to network. This layer represents the services. Now, whatever UI may be, in a way, what application you're using, the face of it, the app itself, the user interface, user experience, everything. What software? It is an app, no, mobile app, Android app. Which Android app? Everything is taken care by layer 7, right? Because all this is abstract. No, can you see presentation layer? Can you see session layer? Can you see transport layer? No, nobody can see any of these layers. But can you see application layer? Yes, we can see. Because why? There is an app, no, that you're seeing, and you're interacting using that app. So overall, how many layers, guys? 7 layers in the USI model. We've got physical, data link, network, transport, session, presentation, application, from layer 1 to layer 7. Any doubts? Have I been clear? Yes, no, maybe. All clear? Then if it is clear, then type a quick yes in the chat. We'll get to TCP IP now. Yeah, explanation was good. Clear? I want people from a non-tech background, maybe preferably from a civil mechanical triple E, and ask them, did you understand? Was I clear? Because CSE and all you've anyway learned, so that is not a big deal. But I really want you guys to also catch up, because while we are doing, when we'll be doing some questions, right? So I want you guys to be on par with the explanation that I'm giving. Yeah. Thank you. Yeah. So this is your different layers in the USI model. Next, moving further, is your devices and protocols. How to put it? These are some of the examples of different devices that we have in each this thing. What physical devices? Again, not devices, not just this thing. Physical devices that we will be using for each layer. Now in layer 1, what different devices do we have? We have hubs, we have repeaters, we have network adapters, we have parallel SCA, SI buses. We've got various physical layer Ethernet, right? We've got different what do you call, token rings, FDDI. We've got IEEE 802.11 devices standard. This is a standard. IEEE 802.11 is a standard in which, so whatever standard compliant devices are, all those fall under physical layer devices. Guys, can you take a quick screenshot for this so that you guys can remember? Physical layer is, one second. Wait, don't take a screenshot. Yeah, take it now. So yeah, what different devices we've got on the physical layer? We've got hubs, we've got repeaters, we've got network adapters. So for example, question comes, right? What layer device is a network adapter? Answer is, yeah. Options are data link layer, network layer, transport layer, none of the above. Give me the answer. Come on. Question is, what give which layer does network adapters belong to? Option 1, network layer. Option 2, presentation layer. Option 3, application layer. Option 4, none of the above. None of the above. Nota, you're not giving a vote, Baba. Answer is none of the above, right? Actual answer is physical layer. Chalo, chalo. Good. Any protocols here? No protocols. Physical is a physical device. No. What protocol will you use here? You can't use any protocol here. Next, data link layer. Data link layer examples for devices are bridges, switches. Ethernet incorporates both this layer and physical layer. So yeah, a general question is, which layer does Ethernet belong to? Once again, I'll just write this. This is over now. I'll remove this. I'll just frame a question for this. Options. What is the answer for this? Answer is 4. Right? So Ethernet operates both on physical layer and data link layer. Now, next, good. Examples for network layer devices are routers. Now, layer 3, see, switches also, be very careful. Layer 3 switches are different from your regular switches. Understand? Right? Your layer 3 switches or IP switches are different from. So your IP switches or your layer 3 switches will work on network layer, while your regular switch that you see. Now switch ante not your fan wala switch. Switch is a separate device in itself. Okay. And bridges also does not mean Howrah bridge. Bridge is also a device. Guys, please don't get confused. So switch, I'll just show you. Let us Google now. Switches in networking images. Yeah, so this is a switch. This is how a switch looks like. Next is bridge. This is how a bridge looks like, right? Multiple, it helps you connect to different nodes from one this thing, right? So your bridge and your switch. I hope I'm clear. I'll also show while we are at it, hubs also will see, no? So this is a hub, basic hub. You must have seen all this in your labs, no? Have you? Yeah? Seen all this in your computer labs? Yes or no? All these devices you must have seen, or maybe in your classrooms also there are multiple, if there are. Chalo, chalo, chalo. Good, good, good. Now that we have successfully completed what OSI layers are, what OSI layer devices are, let us move on to the protocols of OSI. Now, there are no protocols that you'll be using for physical and data link layer, because it is more sort of a physical device that ensures the transmission of data. While on a transmission of data from network layer to your application layer, we have different protocols. So if it is a physical transfer here, a physical existence here, you will have logical transmission of data here in protocols. Physical means physical, like it exists in reality. Logical means it exists on the computer, zeros and ones. Now what different protocols we've got on network layer? IP. Yeah, we've got IP, we've got IPX, we've got NW-Link, NetBUI. Yeah, yeah. So what does IP stand for? IP stands for Internet Protocol. Yeah, yeah. IPX stands for Internet Packet Exchange, Network Links, and all these protocols. Take a screenshot for this also. I hope the screenshot will be there. Taking a screenshot. So what different protocols we've got a network layer? IP, IPX, network link, etc. Transport layer, and this also is a question, guys. What protocol is common for transport and network? Answer is yes, NetBUI. You've got TCP, SPX, network link. Network link also you can take. In your session layer, you've got NetBIOS. In presentation layer, you've got NCP, AI. Application layer, we've got SNMP, we've got SNTP, we've got FTP, Telnet. Yeah, take a screenshot, please. We've got simple network management protocol, simple mail transfer protocol, file transfer protocol, Telnet, hypertext transport protocol. NCP is network control protocol. Yeah, different protocols each for each layer. Yes. So yeah, OSI. Can I call OSI done? Are we clear with everything? You want a screenshot for this? Yeah. Yes, this is the most that I can do. What if I go to presentation? Yes. Yes. Yeah. 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 So take a screenshot if you wish to. Right. So we've gone through the different layers of OSI, we've gone through the different devices within OSI. Tell me, we'll do a quick revision, okay? Keep typing and keep asking you questions. That's okay, I'll share the PPT later on, guys. I'll share it to sir, Subhash, sir, and he will share it to you. Okay. Quickly, I'll start asking you, sir, a few questions. What questions should I ask? Okay. Repeater is a which layer device? Repeaters is a which layer device? Physical layer. Right. IP protocol belongs to which layer? Good. Network layer. It is a physical layer device. Now SFTP protocol belongs to which layer? Application layer. Good. Yeah, pretty much it. Remaining all I guess you're clear with. So yeah, OSI is done. Let us move to our next layer. That is your TCP IP. Right? Shall we? Yes. Clear on OSI. What OSI? Different layers are what different. Yeah. Devices we use. What different protocols we use. Yes. Good. Once again, people from non-CSE IT background, if you say it will instill more confidence with me. So that I can move on happily to the next sort of communication models. Yeah. So next is TCP IP model. And TCP IP model, see guys, this is a plain simple explanation. We need not beat around the bush, right? TCP stands for Transmission Control Protocol, IP stands for Internet Protocol. Whatever the data link layer and physical layer does, here it is taken care by physical network interface subnet layer. Physical layer basically takes care of these two in the OSI model. The network layer is taken care by network layer, but generally network in TCP IP is internet. Yes, your regular internet that you see. The transport layer is transport layer. Duties are pretty much the same. Session layer, presentation, and application layer together comprise of a single layer here called as application layer. Right? Take a screenshot of this. Whatever physical layer you've got in TCP IP comprises or is responsible for all the responsibilities of data link and physical layer. Right? I'll ask you a quick question, okay? Which layer is responsible for encryption of data in OSI? Some say session, some say transport, some say presentation. Somebody said section. Oh, super. Tell me one thing, transport or presentation or session? You are only giving me multiple choice options. Somebody said network also. Come on, guys. I need one single answer. Yeah, presentation, transport, or network. You are selling session also. So you are giving me option A, option B, option C. Let me go back and see. No, where did I have this? Yeah, see. What does it say? Presentation layer services. Presentation layer services include data encryption and text compression. Agreed? Yes? Yes? Moral of the story is? Moral of the story is keep 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 your eyes focused. Remember what you're learning. Okay, just a second. Sure. No, it is not transport, it is presentation. Coming back to TCP IP, right? Coming back to TCP IP. So tell me which layer of TCP IP model is responsible for encryption? Yeah, sure. moving further, just a second, guys. Let us, we are falling back on schedule. So different protocols. I hope you've understood the layers, how the layers are split between TCP/IP and OSI. Let us move further immediately to the protocols, different protocols that we've got. The physical layer basically. So see four major layers in TCP/IP, right? Physical, network or internet, transport, and application. Only four major layers. So I'll take you through different protocols that are there. In your physical layer protocols, we've got Wi-Fi, we've got USB, RJ45, SDH, MW, Ethernet, TPP, frame relay, and etc. So these are the different protocols. There are many more protocols, but major ones I'm listing here, which have been previously asked for stated or taken major protocols itself. So your physical interface or your physical layer basically uses these protocols, Wi-Fi, USB, and all. Internet or your network layer, it is called as network layer or internet layer. It uses IPv4, IPv6, OSPF, RIP, BGP, ICMP, right? Um, then in your transport layer, you've got TCP, we've got UDP. Yeah, TCP is TCP and UDP. You know what is the difference? What is the difference between TCP and UDP? Major difference, you tell me. Single word. Major. First, whenever you heard, yes, connection, yes, which is connection less, which is connection full, connection oriented basically. Yeah, which one? UDP is connectionless, right? UDP protocol is connectionless, while TCP is a connection-oriented protocol. Now, in application layer, basically we have so all this TCP and UDP, both these connectionless or connection, basis on which the data is supposed to be transported is based on the transport layer of your TCP/IP. Next, application layer comprises of DNS, DHCP, FTP, Telnet, email, WhatsApp, and all not required. So these are the different protocols in your TCP/IP. Next, we've got different devices, right? We've got different devices. Just a second. Yeah. So these are the different devices in your TCP/IP model. One is your application. First, we'll start with your physical layer devices. We've got hubs, repeaters. So they are the same from this. Let us check. Hubs repeaters were there in OSI physical layers also. Hubs repeaters are there in physical layer of TCP/IP also. Obviously, we require layer 2 switches, bridges. Here also layer 2 data link switches. Okay, and I'm just comparing, right? Your routers, yeah. So network layer, no physical network layer in OSI had what? Network layer, routers layer 3, yeah. So routers are always layer 3, but layer 2 in terms of network. So routers are always a network layer device. Yeah, layer 3 switches are also a network layer device. Next, in transport, we've got some firewalls, load balancers, not devices. These are merely are more sort of uh, protocols or applications, you can say. Load balancers, right? In transport layer, you know what load balancers are, right? Say, for example, if you've got system one, right? I'll just show here. So you've got, instead of systems, I'll call it server one. This is necessary because load balancer, you'll have a question in network security. Now imagine you've got server, you have a website. Yeah, you have your website which gives out results. Now the website is deployed on server 1. Put this aside for a while. There is only one website, and server 1 can take 1,000 students. Server 1 can take 1,000 students. Now, if you are to deploy your website on this server, it can take only 1,000 students. Whenever the 1,001st student comes, the server will go down. Yes. So that is a problem, right? Now, what will a load balancer do is, right? As soon as there is a 1,001st user here, okay. If you're in terms of AWS, you have something called as ELB, Elastic Load Balancer. It will, you can define, it redirects the 1,001st user to a server 2, which can also take 1,000. So your users from 1 to 1,000 will go to server 1. Obviously, you can decide it is and as you wish. Basically, you can also go like first user to server 2, server 1, second user to server 2, then third user to server 3. You can design it in any way you wish to. But generally, what happens is if 1 to 1,000 users, all same website will be on all the three devices, on all the three servers. So it's 1 to 1,000 users will go on to server 1. Now from 1,001st user to 2,000 will go on to server 2. But see, user cannot go by themselves. No? There has to be someone who is sitting in middle, right? There has to be someone who is routing these users to these particular, right? Agreed. So that is basically taken care by a load balancer. Just as the name suggests, it balances the load. Clear? So this is a load balancer, right? And there are multiple users. Yes. See, user 1. Yeah. So there are multiple users here, right? So these users will direct to the, will each one of them will hit to the load balancer, and based on the user count they'll move to server 1. So a load balancer does is it defines how much it has access to, how many requests are happening on server, and it has access to how many requests are happening on server 2. It has access to what is happening on a server, how many requests are there on server 3. So as soon as a new user comes in, it will decide, okay, let me send it here, or because the load is less here, or let me send it here because the load is less here. It will decide it. Now this is what a load balancer is, right? So your load balancers are part of your transport layer. Now application layer, you've got end devices, obviously, like your PC, your server, your phones, right? Your intrusion detection systems, your firewalls, etc. Yeah. Moving further. So guys, is TCP IP clear? Type a quick yes in the chat, please. If TCP IP is clear. Sorry. Sure. So now that quick recap from beginning, the two layers. Uh, Physical layer is what? Physical layer. Let us recap OSI layers first. Recap of OSI I'm doing here. Physical layer defines all electrical and physical specifications for devices, includes layouts of pins, voltages, cable specifications, etc. Defines cabling and connections, transmission data over physical media. Physical layer rangane, you have to remember this. Transmit data over physical media. Physical media ante enti? Tell me. Your cables, right? Type C cable, maybe. It can be any other cable that you think. Next is data link layer. Data link layer transmits data in what format? It transmits data in frames, right? It transmits data in frames. It ensures reliability of physical layer, as I remember, as you remember. Standards define how data frames are recognized and provide necessary flow control. So blah blah blah. Data link layer majority important that you need to understand is it transmits data in frames across different network segments. A part of a network you can call it as a network segment. Okay. Next is network layer. Establishes, maintains, and terminates network connections. So first of all, connection has to be established, right? So everything is taken care by network layer. Routes data packets. How you transmit data in frames in data link layer, you transmit data in packets in network layer, right? Next, in transport layer, we have basically this is where the transport end-to-end transport happens, right? From what do you call, from system 1 to system 2, the transport of data happens from the transport layer. In session layer, it opens conversations, closes conversations, maintains the discussions, creates a session basically, so that every time you need not introduce yourself as a new system while you are sending data. Next is presentation layer. Presentation layer is basically helps us in data encryption and text compressions. Application layer is the face of all this thing, like the UI itself, the application itself, right, through which you can initiate or control or interact basically. So that is OSI layer. Different devices in OSI layers are hubs, repeaters, network adapters, parallel SCSI buses, right? So yeah, and we've got data link layer. Data link layer devices are bridges, switches. Switches are layer 2 switches. Layer 3 switches are different. Layer 2 switches are different. Ethernet incorporates this layer and physical layer, right? Network layer devices include routers, layer 3 switches, right, or IP switches. And protocols, in network layer, we've got IP, IPX protocol, we've got TCP protocol in your transport, we've got NetBIOS in your session, we've got NCP in your presentation, we've got examples, these are SNMP, SMTP, all the famous protocols that you've heard is part of application layer. Then in your TCP IP model, you've got basically in high level overview, your responsibilities of data link layer and physical layer are taken care by the physical layer of TCP IP. The responsibilities of network layer in OSI are taken care by the network layer in TCP IP. The transport layer in transport layer in TCP IP, and your application presentation session together, the responsibilities are taken care by application layer of TCP IP. Now, different protocols. What protocols do you see in TCP IP? We've got physical, all the physical layer protocols that it uses is Wi-Fi. See, the data is all, what do you call, without like majorly without cabling, only when cabling is involved when it comes to Ethernet and all. But genuinely, a lot of data happens over Wi-Fi or your USB, yeah, or your Ethernet, yeah. And network layer in what do you call, OSI is internet layer in TCP/IP or network layer. So different protocols we've got is IPv4, IPv6, yeah, OSPF, RIP, BGP, ICMP. If you wish to know your IPv4, IPv6 address, then you can simply open your CMD and you can type ipconfig, right? It will give you what IPv4 is, what IPv6 address is. Just open up your systems. In your systems, just press Windows plus R. When you do Windows plus R, type CMD. That will open up a command prompt. Just type ipconfig. Okay, it will give you different whatever we are learning here. No, you'll see certain ideas here. Okay, what this is, what IPv6 addresses, what IPv4 addresses, and all. Right? Yeah. Now in transport layer, we use TCP UDP protocols. In application layer, we've got protocols such as DNS, that is domain name service, DHCP, FTP, Telnet, etc., etc. Then devices, we've got hubs and repeaters, same as OSI devices. Yeah. Modems, modem is what device? They'll ask. Modem is a physical layer device, sir. You should answer. Layer 2 switches belong to which layer of answer this? Layer 2 switches belong to which layer of IP model? Answer this, guys. Layer 2 switches generally belong to which layer of TCP/IP? Sure. Good, good, good. Layer 1. Layer 3 switches. Layer 3 switches. Give me an answer for layer 3 switches. Layer 2. Right. Good. Then your different devices include your load balancers, firewalls, right? We learned what load balancers are. Then application layer devices include end devices, firewalls, etc. Next. Any doubts till now? Yeah. Any doubts till now? Everything is clear. If it is clear, then type a quick clear in the chat. Just say clear. That will help me to understand. Sure. Good, good, good. Just go through this, not in that time. All right. Now, moving further, I do you guys know what an IP address is? Yes. Do you guys know what an IP address is? No. Come on. What is an IP address? Yeah. Every system has one ID. I am not able to see your answer. 51 years. 149. Logical address of system in the network. Logical address of a system in the network. Which network? Which is the network are we talking about? We are talking about the internet. Now, what happens is when you are in the internet, see, we are all discussing together, right? This is an online class that is happening over Zoom, basically. So what happens is we are all, see, whatever I'm telling from my home, from my place here, from my system, is traveling across the internet, going to your system correctly, right? And then you are able to hear whatever I'm telling clearly. You're able to see every data that I'm sharing my screen on, right? So all this is happening, right? This is because the core, in its core level, what we are doing is every system or a network in the internet is uniquely identified by a, you can call it as a number, sequence of numbers, or you can call, some call it as a label. Now this is called as IP address, right? So there is a specific address, just like we've got an address code basically for every area that we've got in India. We call it as a pin code or a zip code, right? Same way, every system or every network on the internet also has wherein if data has to go to that particular network or that particular system, that system will be identified using this particular sequence of numbers. Now, this is called as IP address, right? Every system or network will have one, and it is a sequence of numbers, right? It is a sequence of numbers when it comes to IPv4, and it is a sequence of numbers, combination of numbers and characters if it is a IPv6. Now, what IPv4, what IPv6 is? See, IP addresses, IPv4 is like a 32-bit address, right? 32 bits are there. It is a 32-bit number. So for an example is your 192.168.1.251. So it comprises of 32 bits overall, right? So what happens is these 32 bits are not enough for the number of systems that are across the world now. So eventually we moved on to something called as an IPv6. Although IPv6 was used long ago, since a very long time, like it was created, uh, you know, maybe in 2005 or 2006. But in general, IPv4 is a 32-bit address. IPv6 is a more longer affair. It is a 128-bit address, IP address only. The use is the same, right? The use is the same. It also uniquely identifies. But since those extra, how much? 128 minus 32 is how much? Extra 96 bits. Yeah. So extra 96 bits we've got. The number of possibilities for addressing all the different systems has increased. So everybody is moving towards the IPv6 only, but nowadays new addresses that they are providing are also IPv6 only. But since IPv4 has been in use since a very long time, most of us still tend to have IPv4 IP addresses. So there are two major IP addresses. One is IPv4 and the other is IPv6. Now, in IPv4, you have different ranges. As I said, it is a 32-bit address. So a general IP address you can say is 192.168.1.251, right? So what happens is the first octet value, right? First, see, when I said 192 dots, say for example, if address is, if IPv4 address is 192.168.1.251. So the first octet in this is the first octet. Based on the first octet value, based on the first octet value, there are different classes of IP addresses. There are different classes of IP addresses, right? If IPv4 address is this, first octet is 192, right? Second octet not required as of now. It is an internal understanding of an IP address. We don't want it. We've got lesser time to understand, but we are here to clear the networking aspect of it, right? So for you to remember as of now, you can deep dive into it later on. But see, based on the first octet that we've got how many classes? Total 5 classes. One is class A that happens from 0 to 127. So example is uh, class A IPv4 example is 0 to what? It is 0 to 127, no? So 120, 120.1.2. IPv4 at class A, right? Same, let us go for class B. Class B is what? 128 to 191 now. So let us do 181. Yeah, 181 falls under that category. 181.1.2.328 maybe. So this is an example of class B. Now let's do class C. Class is what? 192, 223. I gave you an example, no? 192.168.2.51. So this is an example of class C. Next is class D. Class D is what? 224. It starts from 224, right? So we can say 228. Yeah. Same thing goes with class E. Class E is also called as an experimental IP address. So all the experiments that you see, any like it is generally it stands for experimental. So if there is a question that says experimental or something in an IP class, straight off go for class E. So am I clear? Is this understood? Yeah. Yes. No. Maybe. Now if I give you an example of, I'll give you an example. Tell me which class it belongs to. Remember this, no? 0 to 127 class A, 128 to 191 class B, 192 to 223 class C, 224 to 239 class D, 242 to 255 class E, right? And I really want to take more time and go into CIDR notations, but I don't think we have that time. So as of now, what is required will go. I'll give you an example. I'll give you 5 examples. Give me which they are from. Which Now give me these 5 answers, guys. Hello? Yeah. I'm sorry. So, yeah. So where was I? I was just discussing. I just wanted to go for a example on IP classes. Yeah. Give me this. See. 201.222. Answer is class C. Next is, since we are on it, which of the following information is present in the IPv4 header but not the IPv6 header? I'll tell you one thing. In IPv4 header, we have something called as time to live. Now, what time to live is? Time to live is, how do I explain you time to live? Wait, I will explain you time to live. Remove this. Don't want this. Don't want this. Yes. Now imagine there is a network of system 1, system 2, system 3, system 4. I'm audible, right? I'm explaining what time to live is. In IPv4, we have something called as time to live. What it is, I'm telling you now. Now imagine data has transporting from system 1 to system N. It can be, so system 1 to system N, data is to transport. We have a time to live of 4. Okay, if TTL is 4, what happens is it goes, actually it is it is in different metrics. I'll show that metrics. So what happens is, say for example, if it is 4, so for one change of data from one system to other system, time to live will fall down to -1. That is what 3. Next, again it will go to system 2 to system 3. Time to live will be -1, 2. Again it will go to system 3 to system 4. It will be -1. So 4, it went to 3, 2, 1. When it goes to 1, the packet is discarded. Discarded means if the packet is traveling through these many number of systems, there is a decent enough chance that the package is not useful. If the packet is transferred from these many number of systems, that means the packet can be corrupted. So generally, every time a data packet is set up, we set up something called as time to live. You have something called, we call it as time to live or TTL. I don't know how many of you have set up Wi-Fi in your own systems, in your own home. You have a value set up there, TTL, and when you go to the dashboard, do you know? Did you observe any time TTL? Whenever you're setting up Wi-Fi or something, we have something called as TTL. I mean, you'd never understand what it is. I'm explaining you what it is. So it is called as time to live. So what time to live does is, whenever it moves to one system, it goes to, whenever it goes to 1, the packet is discarded, because next system it will be 0 and the packet will die. So what happens is, there is a certain number that you're assigned, time to live packet number. This helps us in making sure that the packet is not revolving around the system. Ipudu, by chance, if the packet in a, see, network means there are a lot of different systems or lot of different nodes. Now each node is connected to each other node. Now what if that packet has fallen into a loop? Instead of it going from system 1 to system N, what if it is going to 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4? If it is traveling, then the packet is of no use, right? So what happens is, if a number of systems is increasing by so and so, then if the time to live for every system will say that, okay, my start system is 1, my end system should be N, and if that packet is going through a system more than N number of, say for example 5 number of times, then our data పంపించి కూడా waste, so you discard it. So that is why time to live -1 -1, as soon as it is 1, the packet is discarded. Did you understand what time to live is? Now, if it will resend the packet again, so 1, 2, 3, again, this time it does not fall into a loop, it will go to your system n as per the requirement. So 5 the 4 and the 4, 3, 2. Before 1 only it reached the system n. So it is successful. Did you understand? Yes, it's sort of an expiry date. Yes, sort of an expiry number count basically. Am I? Are you clear with what time to live is? TTL is? Okay. Can I please repeat? Yeah. Say for example, there are multiple systems on a network. This is entirely a network, and on each in each network there are multiple systems or nodes. What happens is if you intend to send a packet from system 1 to system n, what happens is since a network is a complex network of different connected to each other, what if a packet falls into a loop instead of it going to system 1 to system n? Like what is the way from 1 to n etla veltadi? 1 2 3 n elpoch kada. But what if it is going from 1 2 3 4 again from 4 it is going to 1? What if it falls into a loop and the packet never reaches system n? That is why what happens is there is an expiry date or an expiry count set up to every data packet called TTL or time to live, saying that if it goes through these many number of systems, then it should be discarded. So if the TTL for one data packet is 5, I'm sending that packet to here, that TTL will become 4. It will go to here, TTL will become 3. Worst case scenario, it does not go to n, it goes to 4. So 5 4 3 again it goes here, TTL will be 2. Again it comes to system 1, TTL will be 1. As soon as any of the nodes have a packet of TTL 1, it will discard them. Any of the packet will have TTL 1, it will discard them. Okay. Yeah. So whenever it happens, instead, so it will retransmit the packet again. So it will say if it is 5 again, it will go to 5. This will be 4, 3. This time it will not go here. It will go to here. 2. 2 means before expiry only it reads, no? So what happens is the packet does not basically end up where it shouldn't be ending up. So, okay. So TTL helps us in making sure that unnecessary packets are not revolving in the network. More the number of packets are more than unnecessary number of packets are revolving in the network. That means the network will be unnecessary heavy. No. So any useless packet there, the TTL will be keep decreasing, and once the TTL is 1, it will be discarded. That is time to live. Are you clear? Did you understand the concept of time to live? Yes. Yeah. Now, coming back to the question, which of the following information is present in an IPv4 header but not in an IPv5 header? Time to live is present in v4, but it is not present in v6 because it is not called as time to live in v6. It is called as hop limit in v6. Okay, it is called hop limit in. So whatever we don't have time to live in v4, we don't have time to live in v6. Instead, it is called as v6. Instead, it is called as hop limit. All right. Okay, I'll just give you, just go through the question once. I'll just give you. Yeah, coming back to. Are you guys clear with IPv4, IPv6? Are you guys? It is same as hop limit is nothing but some similar to time to live only. Hop limit is nothing is similar to time. What do you call time to live? But it is a different name here, and it is a different name there. So if the question comes, what is there in V4 and not in V6? The answer should be this thing. Okay, all right. So now that we are completed with V4 and V6 headers, next question we have something called as Hamming distance. Now this is also a generic, basically, a question that occurs in Accenture. What happens is he generally asks what Hamming distance is. Now, how do I explain you Hamming distance? Just I'll give you an example. So what Hamming distance means is, do you remember Hamming distance in your CN? Did you have Hamming distance in CN? Yes? No? Okay. So what Hamming distance basically means is, guys remember, it says or it describes how different is one string. String, no? You know what a string is in programming? How different one string is from the other string. Say for example, if my example is, okay, let us say my name is Harsha. This is string 1, S1, and S2 is Varsha. So how different is string 1? Can you explain me? See, on a basic level, you tell me on a generic level. As soon as you see what immediately what you see, what is the difference? What is the difference in S1 and S2? V and H, right? Good, good, good. So V and H, right? So what Hamming distance means is how different is S2 from S1? The only difference is of a single character, right? Only V and H is the difference, no? So your Hamming distance becomes 1. Getting it? Since S1 and S2, S1 is Harsha. What is the difference between S1 and S2? Only single character difference, no? So Hamming distance becomes 1. I'll give you an example. Give me the Hamming distance for this. Let us discuss one more example. Say, what example do I go? Hmm, we have restrain. S2 is refrain. And E does not, no, not a good example then. Just a second. A, B, B, C, D, A, C, B, B, C. What is the Hamming distance for this? Hamming distance is S2 from S1. Only single character, right? Yes or no? Yeah. Same thing. I'll give you a few examples. Let's do this. Now give me examples for solve this. Come on. I'll give you 5 minutes. I want everybody to please solve this and give me the answers. Yes, done. Yeah. So let us try what Hamming distance for this answer is. Sure. So S1 is 100. Am I audible? Yes. Yeah. So 1, so 1 and 1 are same. So different. So 1, 2, 3, 4, 5. So first answer is 5. Answer 1 is 5. Good. Next. 1. Answer 2 is, so this should be 5. This is 1. 1, 0, 0. So this is 1, 2, 3, 4, 5, 6. Yes, so this is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how different this is. This is 1, 2, 3. That's it. So 1, 2, 3. Yeah. Now answer this. I have some message from a coordinator of yours. I just missed it just a second. Good. Chal. Now, now let us focus few questions here without any further ado. Which of the following is correct for a router? It has single collision domain, it has multiple collision domain, it has a single broadcast domain. Okay. So guys, I need you to understand what a collision is first. So collision domain is, as the name implies, a part of a network where packet collisions occur. Now, a collision occurs when two devices send a packet at the same time on a shared network. Let us go back to our drawing board. Imagine this is our network. Yes, and there is, yeah, there is a hub switch or device here. Let us think. Let's say the collision occurs when two devices send a packet at the same time. Now, for example, if this is a hub, let us imagine this is a hub, a switch. Switch is example. Which is a good example. Now, what happens is when system one sends some information to here, and it has to go to system 4. At the same time, routing system 3 to build a software application or a software as a service, while infrastructure as a services access. What does it get? It gives access to physical capabilities, VMs. What does a VM stand for? It stands for a storage. Yeah. So what platform? What basically software as a service is? It is an application that you or us or me we all use, right? Platform as a service gives access, or it helps to give you a runtime environment or the deployment or development tools, like using which you can build a software as a service. Infrastructure as a oh, did I mess up? Structure. Yeah. So infrastructure as a service gives access to physical, say for example, you want access to what operating system you want. Say for example, if you want to understand if how do I put it? I want a 6 GB RAM on the cloud with so and so operating system. And I want a user to get access to such a facility or service. Then we have to build something called as infrastructure as a service, where we are giving them access to multiple physical infrastructures, obviously from remotely only using your virtual machines. That is why I said VMs. And also we give them access to a lot of storage that is out there. So you can define, say for example, in Amazon or AWS, we have something called as T2 micro, T2 large, or T1 large, anything of those sort, right? Wherein you are giving access to a physical infrastructure remotely. Such a scenario is this thing. Now let us what do you call? This is basically your platform as a service, software as a service. General question is, which of the following gives access to the runtime environments, development or deployment tools? So immediately your answer can be, let me see if there is anything here. Yeah. We have something called as Microsoft Azure is an example of which type of cloud. Now, Microsoft Azure is infrastructure as a service, because it helps you in Azure. You can define in Azure you can decide, okay, I want so and so particular storage, 6 GB RAM server, 128 GB ROM server. This is the virtual machine I want, and this is the amount of storage that I'm looking for. As I said, uh, yeah. So these are few cloud necessary cloud components that we want. Now let us do some more problems. We've done this. We'll go through each one of them quickly, okay? These were the basics that were required, but I need you to understand that there are a lot of in-depth questions that are also out there. So I'll try to limit them as much as possible. But if you're not able to understand, that's okay. There will be practice tests that will be given wherein these questions will repeat, wherein it will give you a chance to again go through these questions one by one and research more on each question, in order to have because we are running short of time. We've only got half an hour and we need to cover all these questions. I'll be taking you through these questions as quickly as possible. Next, which of the following is an application monitoring or an observability service? We've got Route 53, CloudWatch, Elastic Cache, EC2. Now, EC2 is a service in AWS. You know AWS, right? Amazon Web Services, wherein in AWS you've got different services that are out there. Now, your services include Elastic Cache, Route 53, CloudWatch, EC2. You've got SNS. You've got Simple Mail, SMS. You've got different services out there. We've got VPC and all, right? So what happens is, which service is mapped for what is where people might get a bit confused. That is why you can simply go to AWS services. Okay, simply go AWS services. Okay, and then you can simply and just have an understanding as to what different services do. So EC2 will do what? Cloud platform, Amazon offers secure, reliable compute this thing. RDS is a relational. Basic your S3. So your basic understanding of Amazon Web Services is enough. I'll tell you what Route 53 is for. Route 53 is generally used as a DNS, domain name service, right? You know what a domain name is. We learned what an IP address is, right? We learned what an IP address is. Say, for example, every IP address, what does a website, if you're watching this particular website called draw.io, now apps.diagrams.net, right? Now this is hosted somewhere on a server, right? Now that server will have an IP address. If we are to access this particular application that you are seeing on that server, then you need to access to that server. Now each server will have a unique IP, right? Yes or no? We learned what an IP address is. Now that IP address, is it easier for us to remember apps.diagrams.net, or is it easier for us to remember 192.168.2.251? Now obviously more number of website means more number of what do you call IP addresses. Now we can't remember these many what do you call IP addresses. That's why we have something called as a domain name service. What domain name service does is it takes IP addresses and maps it to these domain names. Now, whenever somebody searches apps.diagrams.net, it will go to the DNS. Okay, whenever somebody searches, for example, if somebody searches apps.diagrams.net, they go to the DNS. In DNS, there is a table which says apps.diagrams.net is mapped to so and so different IP address. And from then they go to that server with that IP address. So this is how it works. So domain name service resolves this particular name to a particular IP address, and that IP address is here. So this is how DNS works. So in AWS, this is achieved using Route 53. CloudWatch is nothing but alarms. You can set up alarms as to how much billing is happening for you. Say, for example, sometimes what happens is we create a lot of servers and you forget to turn off the server. So your bill will keep on increasing. So Amazon AWS, they help this to solve this using a service called CloudWatch. Just as the name suggests, CloudWatch, what happens is they monitor and observe. This particular service monitors and observes what is the payment, so how much billing is going on, how much utilization is going on, and based on that it will give us an alarm. So you can set up a particular alarm using CloudWatch, right? Next is Elastic Cache. Elastic Cache is a cache service from AWS. EC2 is Elastic Compute Cloud. You can create instances, or you can create virtual machines basically as instances again using EC2. So which application monitors and observes among these three? CloudWatch observes, because Route 53 does what? It does DNS. Elastic Cache is a cache-oriented service. EC2 is a instance. We create instances using EC2. So which one is more understandable? It is CloudWatch. So the answer is CloudWatch. Now, which of the following is used to establish a VPN connection? Now, Nginx, Zeus, and HA proxy are what do you call? Uh, uh, they help us to basically. Once again. The answer is, the question is supposed to be wrong, I believe. Yeah, this should be is used to establish a connection service. So in your AWS, basically we have got OpenSwan. Not just AWS in general, for your Linux also. Nginx is more sort of utilized for your server oriented. Zeus and HA proxy are not services that we use to establish. OpenSwan is the most famous VPN connection service. Now we did this also, TCP/IP. Which of the following protocol is used on link layer? We did this, right? ARP, UDP, DNS. So answer is ARP, because these three are not from the link layer. Let's do this. In the internet, checksum technique is mostly used at which of the following layers of OSI model? Checksum technique is used mostly at OSI model. It is network layer and transport layer. Yes. We'll go through each one of them. Now, in cloud computing, which of the following resources can you answer this once for me? If you remember, I had told in cloud computing, we do virtualization at which layer we use it, for which service we generally use virtualization for, on infrastructure as a service. Right. Now, same question. Which protocol belongs to the internet layer? You know, SMTP belongs to application layer, TCP belongs to transport layer, UDP belongs to transport layer, which is the only thing that is pending, that is ARP. So ARP belongs to the internet layer. As we said, terminators are which type of topology? Terminators are used in bus topology. I'm just checking what different. This is again class C, we did this, right? Come on, give me an example for this. We'll go back to our PPT. Which of the following network device works only at physical and data link layer of the OSI model? Network device works only at physical and data link layer of the OSI model. We've got switch, router, bridge, gateway. Physical and data link. Hubs, repeaters, network adapters. Ethernet is there. Bridge as well, I believe. These are also a part of this thing. Next, we've got 242, 254 first octet value. Which one? Class E. We have done this. For router, it has just two. Which of the following is an example of infrastructure as a service? Classroom is a software as a service. Stratos is also a software as a service. DigitalOcean, it is something similar to your AWS and your GCP, right? So DigitalOcean is also a infrastructure as a service where you can define what VMs you wish to have. Yeah. Now, from starting. Now, guys, I need you to understand few things. First thing is a lot of, see, if you see just what we just did here right now. Yes, we'll share the questions, not to worry. If you see the PDFs that you've seen, different questions that we've seen, a lot of networking oriented questions, let's face it, are sometimes in depth that are asked, and some of them are upfront that are asked. So your fundamental wise, if you whatever I've trained you in the last 2.5 hours, fundamentals are set for you guys to understand. We all know what a data link layer is. We all know what physical layers are. What we all know what different models are. We all know what services are there in cloud computing. Obviously, 3 hours is not enough for me to cover all this. For example, this AWS data migration services, I cannot explain within 3 years, but what I can tell you is, you can at least, with what fundamentals that we have given, we can cover at least 40 to 50% of the question papers. Now, the remaining 20% or 30% depends on how well you practice these questions that we are going to share with you, right? How well we are going to share with you. Now, say for example, I just explained you, I saw a question with some this thing, no, here somewhere around. Just a second. Uh, where is it? Where I just saw a checksum session. I just had seen a. Just again, let me just search for. Yeah, for example, in the internet, the checksum technique used is mostly used at which of the following layer. Now, you know, for this to be explained, I need to explain you what checksum techniques are. Checksum technique is mostly used for error handling and error detection, right? So error detection, error handling, answer is 1 and 2, network layer and transport layer. If you can go here, if you go here, so your error detection that happens for each layer. I told you, right? I've told you error detection happens at almost all layers here. See, error handling. Uh, where else do I have error handling? Error handling here also. So all this error handling, there are different techniques that are used. So which used for error handling, and it is generally used at your network layer and transport layer. So these sort of in-depth something is difficult for anybody to discuss within a span of 3 hours. So what I want you to do is, we'll share the questions. We will be giving you certain, what do you call, practice papers. Go through those practice papers. Make sure that you're able to understand the fundamentals. Firstly, for example, if several government entities, let us do this, or else wait a second. If several government entities decided to have a common cloud platform storage, then which type of deployment model should be used? Now there are different deployment models. Okay, one is public cloud, private cloud, community cloud, hybrid cloud. What public cloud means is, public cloud means it is open for all. Security is weak. Private cloud means it is open to only selected individual networks or nodes, and security is highest. Community cloud means when more than one. See, in private cloud, only one, what do you call, entity is using it. Now, what if 3 or 4 entities together want to use a private cloud? Then in such a scenario, apart from those 3 or 4 entities, nobody else will be using, right? But it is not even a private, because not it isn't a single entity that is using it. 2 or 3 are using. So in such a scenario, we call it as a community cloud. Hybrid cloud means it is a combination. Now what happens is, some of it is private, some of it is left open to a community, some of it is public, while some of it is used by a certain number of people. So there is a hybrid model that is used. Now you can see here, if several government entities decide to have a common cloud platform for data storage, but they are all government entities only, right? So, for example, can separate a private entity come and access the data to this? No, they cannot access the data, because only government entities want to use that data. Now, in such a scenario, one or more, see, apart from those government entities, nobody will be using. But are they a single government entity for using private cloud? No. Multiple entities, but within the government they are using. That's why we call it as a community cloud. So the answer should be community cloud. If if an entity is opening, for example, a website is open to the public, right? In such a scenario, for deploying a website, we use a public cloud. Now, for example, if what do you call, password management, we have a few password management companies. Now these password management companies, do they want to share the data to anybody else except for others, sorry, except for themselves? No, right? So in such a scenario, they'll keep their data private to them, their users data private to them. In such a scenario, we use a private cloud. Now next, so few questions like this you might have to figure out on your own. Your internet is always at your service. Questions and right answers we'll be explaining you anyway. We'll be sharing with you. Next is in application layer of TCP/IP, which of the following protocol is used by router for transferring files? Right. So we use FTP protocol. We use TFTP protocol. We also use NFS also, basically. So all of the above should be the answer. Right. Okay. The reporting services of cloud helps in monitoring billing, ensuring optimum usage, or automation. Now, reporting services, they basically help in monitoring and automating, reports, but they do not ensure you for optimum usage of resources, right? They do not make sure that you are utilizing. It is up to you. They are only useful for monitoring the billing. They are responsible in order to build an automated what do you call pipeline, maybe a monitoring service using Dynatrace or something. So in such a scenario, you use a reporting service, but generally they do not help in ensuring the optimum usage. It is up to what and how you have designed your VPC and all. Right? Reporting services have nothing to do in that. So design principles what you are using. So since such a scenario, in such a scenario, you are only use reporting service are only monitoring the billing and automating any pipelines. So the answer should be 1 and 3. Next is now the higher order bits of first order of class E. Right, first order of class B, right? Yeah. So the higher order bits for first order of class B are always set to. Now, understanding higher order bits, what I can do is you can perhaps understand for which you might have to require. So what class E belongs to 240 to 255, right? So you need to understand that there are set bits for each and every this thing. Now I cannot explain everything for this, but in general, I want you to remember is we use all 1111 for they are the higher order bits for class E. So everything it starts with 1111 00011. So all your higher order bits for class E are 4 ones to begin with. Next is what else can we this. Now let us do a security from the given example below. Find out the type of cyber attack. If a hacker attempts to get into the admin section of a site xyz.com, they may type in /admin. This will bring up to an admin login page, and in some cases, the admin username and password may be default admin and or very easy to guess. The attacker will gain access and manipulate to steal data at will. Now, what this means is, right, the answer here shouldn't be SQL injection. The answer should be URL interpretation. Generally, what happens is you generally guess the common URLs that are out there, because a lot of admin websites are by default, for example, WordPress websites. WordPress websites generally a common practice is their website name.com/wp-admin. So that is a common website. If a hacker gets to know that your website is on WordPress, they'll simply go to /wp-admin. And then whatever the default WP admin username and password are there, they'll try to enter and get access to your server. So in such a scenario, such an attack is called as URL interpretation. What SQL injection means is whenever you wish to attack the internal database of the system from your front end of the website, you simply run SQL commands bypassing the filters. And you can perhaps run an SQL query right from your website. Now, in such a scenario, such an attack is called as SQL injection. DNS spoofing. What DNS spoofing means is
As I said you, this we had, right? So DNS. So when somebody searches for this in DNS, you have app.diagrams.net, and it then sends a preferred IP address. But what if I had the DNS or proof the DNS, saying that whenever somebody searches this, it has to go to my website and not the actual website, right? So in such a scenario, whenever somebody searches for apps.diagrams.net, instead of going to the original, it goes to the fake website. So it is a very common attack. It is called as DNS spoofing or ARP poisoning attack, ARP poisoning attack. So, where is the question there? Yeah. So that is DNS spoofing. One is denial of service. Now, what denial of service does is, what if there is a system? Okay. And as I said, servers, if you remember, server 1, server 2, server 3, we had. Imagine this is server 1. Okay. Now this is server 2. Server 1 and server 2. Now server 1 has a load of 1,000, but what if we are setting up 1,000 systems and giving access without their the by default you will not put basically 1,000 systems, but you can send 1,000 requests from a single system, right? So if a server can only take 1,000 requests from 1,000 systems, from one system if I send 1,000 requests, then there will be unnecessary overload, and other people utilize like this will not be able to access the server, right? Now this is called as denial of service, wherein you are overloading the server with multiple requests and getting the server down. Now, how do you prevent denial of service? You can prevent denial of service by using something called as the load balancer. Remember, I had discussed before, right? So all in all, what I'm trying to tell you here is there are a lot of questions which I want to discuss, but then it will go over my hours of now. But majority of the fundamentals that I have covered, I think is enough for you to cover, upfront. Moving further, all the questions that will be asked in your what you call assessment, practice assessments, I want you guys to please practice those assessments. And in a few of your questions, you might have to remember, because they are something that this is not networking is not what you call networking out cloud security is not a deduction oriented section. It is more sort of how well you remember this. Right. So that is my explore as many questions as possible. You need not go outside and explore also whatever questions you are sharing in a practical exam is more than for you to take it further and clear the cutoff. Yes. For example, coefficient of x term x bar 0 in a good polynomial generation should be. The answer is 1. I mean this is something that now for this you might have to, as I said, you need to understand a lot of different factors. This is already. Which of the following statements is correct for data migration and supports homogeneous migration to Oracle to Oracle? The answer is it supports homogeneous migration from Oracle to Oracle and also from SQL. In terms of operational data migration, this is not possible because if the source database is an operational, how can it send data? The whole point of migration is to send data from one point to another point, right? If the source database itself is an operational and not sending data, so the answer is 1 and 2. Yeah, that is about it, guys. I'll share questions. I hope you have understood the fundamentals correctly. I will share the concepts once again, all these concepts that I have discussed.
make sure that you are clear with all the concepts, basics for OSI, TCP, IP, your devices and your protocols are important, your IP class ranges are important. Collisions, we've explained hub is always a single collision domain, while switches and routers are multiple collision domains. Broadcast domain is also pretty much the same. You can see, I'll share the PPT. You can do research on that. That's about it. Thank you so much. Any doubts you've got, let me know now, or else we can close the session for now and we can plan for the next session. I will share. Have I missed any questions? Just a second. Somebody asked a having distance question. We were on to a different question back then. You asked if the size is different, right? What if the size is different for each thing? Now you have something called as C's. Should strings be of the same length? What if they are of different length? Now you have normalization techniques for that. Again, I don't want to go in depth with that, and I don't think they'll ask you also. But in general, you have normalization techniques which generally get them down to equal sizes. And also, why having distance is used is because by the time the packet is transferred, if you are able to figure out the errors, see the difference of bits will explain you how much error it has. Original bit and the data transfer, after transfer, what the data has evolved or changed to. So based on that, you can figure out, okay, this is where you need to what do you call? This is where the errors are happening. This is where you need to handle errors. You can figure out. So for that very reason, having distance is important. Yeah. Okay, guys. Thank you. All the best. Next session will be perhaps at 2 o'clock, if I'm not wrong. Please go through the practice material that we'll be sharing for Accenture networking at least. Remaining tips and tricks sections, others will let you know. Other faculty will let you know. Thank you so much. I'm closing the session now. Thank you.